Life's good. A lot of this information, you will have seen some of this stuff and heard some of this stuff in previous math classes. I would bet you a lot of stuff for the first 9 weeks, it's stuff you had definitely heard about. Now, you might not be a master at it, which is okay, but you might have heard about it saying, oh, I get this. Okay, so there's all kinds of things they name in statistics. So you have variables. Let's stop there. A variable. What was a variable just in algebra? Anybody? Give me an example of a variable. Yeah. X. Yeah. In math, we use X, Y, Z, Greek letters, Roman numerals. We use all kinds of things for variables. So variables are characteristics or quantities that can be measured or counted. Okay? Variables take different values for different observations. So variables in algebra, usually if we were solving for x, variable, algebra 1, if you had this equation, 2x is equal to 8, just going through it, you said, okay, we're going to solve for x, and so you'd get x equals 4. This is not really necessarily related to statistics. So variables in math, in algebra, and calculus, things like that, would be a letter. A variable here is still kind of an unknown, and we can list things saying, hey, x is, but now we're going to say that x would probably go along with a group of stuff. Okay? Observations producing single outcome of each variable. Sample is a group of observations. So I just kind of skimmed through that next thing. So an observation, you have done observations all your life. Agree? You've noticed stuff. You probably know which way to get in and out of this building a little bit faster than those kids that are only about 4'2" that are here, called the freshmen. But bless you. But when you're a freshman, you're like, I'm getting all caught up in the bottleneck stuff, right? So you have made observations. Okay? If you do something that hurts, and you do something and it hurts again, and you do something that hurts again, you might not continue to do what hurts. Okay, so you're observing things. Okay, and a lot of times in observation, you'll start noticing things. Let's take just traffic patterns. Okay, so you're going to realize ways to get to certain places, and you realize some roads are better than others. Now, one observation people might make as you're driving up in the mountains, or on C470, beyond E470, is there's toll lanes. What do you notice about the toll lanes? Those guys are doing 75 miles, 80 miles an hour, and everyone else is kind of bottlenecked. Okay, what's the observation there? You made the observation that you could choose to pay money to drive faster and get there quicker, or you could choose to be disgruntled and say, the government needs to provide me roads, and therefore I'm not going to pay. Okay. It's your choice. I'm not saying the right or wrong. But you will figure out things by making observations. You're able to determine why are we making a lot more toll lanes these days? Yes, we'll have a road that will go the same place, but we have a toll lane that you have to pay to be in. Why did they do that as far as state of Colorado? Any just thoughts? Yeah.
They get better funding from private construction companies and stuff. So essentially, you're not using taxpayer dollars, so you can go through those.
Okay. Yeah. Absolutely. Yeah. Yeah. They built it. One, it's hard to get that tax base going. Hello, my friend. We're just looking at that front page. So, one, it's hard to raise taxes because people don't want to pay taxes. Okay. I don't want to pay more in taxes than I absolutely need to. Hey, we need to raise taxes to pay for this. Well, I don't even use that road, so why should I pay for it? And I'm being, a little sarcastic about it, not to be mean. That's basically society looks at it. And this is the most unimportant piece of paper you get all day. Deal? So, one thing I think we might all agree on is if you choose to go to the mountains via I-70, there is definitely times and days of the week, that's horrible. These days, if I want to go skiing up in the mountains, I'm playing hooky from school. I don't want to deal with traffic on Saturday morning or Sunday. That's just me. But have they put anything in place that really makes a difference? You give me a toll lane that lasts for 2 miles, so I go from gridlock traffic to get in front of about 50 cars to go back into gridlock traffic? Is that a solution? That's a good money-making scheme because those people I needed to get 50 cars in front of the rest of the pack to get back into a line that's crawling. But, so there's some observations. Oh, I just gave my packet away. So, they're obviously, in that kind of scenario, we want to try and, as a state, or as a city, or as a whatever, maybe figure out how we can solve a problem like that. So observations, traffic jams, they stink. Let's face it, no one likes sitting in their car going, oh, come on. All right, so a sample would be, let's say I am sitting at the intersection of C470, I-70, basically as the loop goes around and I-70. And I want to take a sample. So I'm going to say, okay, I'm going to count the number of cars on a Friday morning from 8 to 9 o'clock in the morning that are going westbound into the mountains. I don't care about the guys that are the eastbounders. I want the westbound. So there's the sample. I'm collecting a sample. I had a certain group that I took a look at. Okay? So could I have a sample of this class? I mean, there's roughly 30 people in this classroom. Okay, there's all kinds of things that we could try and take a sample of. Who's wearing black shoes, who's wearing white socks, who's wearing colored socks, who's wearing shoes that have different colors, who's wearing, and shoes are a real safe thing, socks are a real safe thing. Who has beautiful hair and whose hair is horrible? You all have beautiful hair. My hair is horrible. Okay? It used to be good. But don't worry, I can't see it on top of my head right now. Got one of those mirrors at home that color on makes it look like I have all this beautiful hair. So I'm just kidding. I always make fun of myself because it's easy to do. I'm an easy target. All right. So let's say you're at a huge conference. You want to record the age of everyone who's present. Okay. Well, the variable in this next thing is age. Okay. And this is kind of a weird thing to take notes on, and you can squeeze however you want to take notes, and you can just listen. It's kind of your choice. So a variable is age, and then it says one person is in the group, is 45 years old, another is 16 years old. Okay, each of these individuals and their ages represent 2 observations. So you observed, just by knowing you have this conference, that someone happens to be 16, someone has to be 45. Okay, so the observation is the 16-year-old and the 45-year-old. You observe that. Okay, the sample would be everyone who goes to the conference. Okay? So everyone who's at that conference is your sample. Okay? Yes, you could break your sample down into subgroups. You know, if we were to say, we're going to talk about Cherry Creek High School. Well, the students at Cherry Creek High School. My sample would be the students at Cherry Creek High School. I could observe lots of things. I could observe freshman, sophomore, junior, senior, or we do have a couple of 4th graders that are taking BC Calc. I don't know how a mind is that advanced in math. Whew. But hey, they're here. That's cool. But we can do that. We can also break down all of the sample of Cherry Creek High School. We could break it into smaller groups and say, we want to do a sample of Stirrups math classes. Well, I have only 4 periods of math I teach. I also teach that medical class. So if you were to take a sample of my 4 math classes, you are part of that sample. You are also a sample of Cherry Creek High School students. If you wanted to say, well, I want to take a sample of Mr. Padovic's math class. Does anyone also have Mr. Padovic this year? Anyone doubling up that I don't know about? You're not part of that sample. I'm sorry. Okay, that's okay. You're still part of a really good sample. My sample. Okay. Next little observation or little thing says, imagine you're a meteorologist. You are keeping track of a daily high temperature every day for 1 full year in Seattle. The variable is the daily high temperature. For each day, the high temperature forms the observations. The sample is collected into a group of 365 days. Oh, we're talking about weather. Don't go tell your science teacher that I'm not for global warming, cooling, climate change, whatever they're calling these days. You all are young, so you more than likely don't watch the news. You might flip on your phone, look at the weather app saying what's the temperature going to be. That's going to dictate what you wear. Or perhaps you're just like anyone else and just say, yeah, I'll wear what I'm going to wear and I'll adjust if I need to. And I saw 2 nights ago, 2 or 3 nights ago, I don't remember. My nights are blended together. The high temperature on this in the past couple days had been recorded in Denver was 103 degrees, but it was in 1890. Oh, we were definitely below that, fortunately, because I grew up in Arizona, so I know what the 100-degree stuff is. But here in Colorado, we feel it from time to time. We're not going to always stay that way. So, meteorologist keeping track of daily high temperature every day for a full year in Seattle. Variable is the daily high temperature. Each day it is a high temperature forms the observation. So you look at the highest temperature each day. The sample is the group of 365 days. Now, you always get the one student says, what about a leap year? Well, we're not worried about the schematics of it. Yes, we should say that it's 365.24772 days. You're like, wait a minute, what? Yeah, that's how long a year is. But now someone's looking it up on the phone. They're going to call bull on it, which is always fine. The majority of things I say to you might be somewhat fabricated. What about this next thing? You're writing an article for a newspaper about people who live in Denver and where they were born. Variable is the birth location. Each person in their birth location forms an observation. The collected group of people who live in Denver used in the study comprised the sample. Okay, yes, you have people who might not have been born in Denver. They might have been born elsewhere. They might have been born in a different state, different country. We don't know. Those are things that we'll do. Variables observations are fundamentally about data collection. Collecting data is done so many places across society that it is impossible to avoid. You will see in this class, collecting data is the first step to attempting to establish statistical evidence. Understanding the nature and behavior of variables is an important first step. So let me just stop. I talked about things that are observations. Okay? Observations don't lead to conclusions. Unfortunately, observations are leading to conclusions by lots of things, and it's wasting time and money. Okay? When I first was brought to this district, I taught my medical class, and I had 1 period of math I taught here at Cherry Creek High School. After that, I would go to all of the rest of the high schools and the district buildings to be a part of helping teachers and to be a part of trying to fathom for the district of money that we should spend. And at the time, they were trying to look at some textbooks that had to be bought that were said to be the best, brightest, greatest. And they're like, these sound fantastic. Let's buy these textbooks. And I just said, wait a minute. What's wrong with the last ones? Well, they don't have all the information. Well, how do you know it doesn't have all the information? Have you actually gone through and compared this textbook to this textbook? Well, no, but this is what the company tells us. That's a sales pitch. Huh. We get influenced by stuff. We make decisions, and unfortunately, we waste time. I can tell you that this building that you're in, many years ago, there was something that came out that was called Common Core Math. You've heard this? Okay, Common Core Math, it's a way of doing math. Now, the people who were here before me said, we're not doing Common Core Math. We're going to continue to do what we do with our own textbooks. And they're like, no, you have to do Common Core. This school here does not react to, hey, look what we have. This school here, and I kid you not, this school is a really big school. It's a really good school. This school does not change direction on what it's doing very easily. It's like the Titanic. It's not that we're sinking. The rudder isn't big enough to make turns quick enough. Nice. So those are just some things. And it was just interesting to see where people get conned into a sales pitch versus, yeah, they're saying numbers, therefore it must be right. All right, let's move on. Enough about that stuff. Okay, variables are quantitative or qualitative. So like write these down. You write down what you would like to, or just listen. Any ideas? What does it say in the next couple paragraphs? Qualitative. What's quantitative? Read that and give me your own best words if anyone chooses. So quantitative variables are numerical in nature. What does numerical mean? Numbers, all right. They measure or count some characteristics: temperature, age, height, weight, grade point average, ACT scores, length, pH, the position of a finish in a marathon, the number of wins in a football season, the inflation rate, and the time it takes to fly to a certain city all provide numerical outcomes. Okay, you're counting it of some sort. All of those variables are quantitative. So we're going to say that we are going to somehow count. Okay, qualitative, take a look at what that next little paragraph says. Second one up from the bottom on that page 1. What's the main thing there in the parentheses it says? Category. Blonde hair, brown eyes, earrings, no earrings, red shirt, black shirt, green shirt, orange shirt. Okay, so qualitative is some sort of category. Okay, so you're labeling a characteristic. So I said hair color, ethnicity, gender, the state or country of your birth, your favorite color, the make and model of your car you drive, or your blood type are all qualitative. Okay, so this is some sort of category. Okay, now, Social Security number, they say it down below, you got to be careful. Social Security number is a number, but it's not quantitative. Okay, because my Social Security number is a certain number that ends in 3 with a whole bunch of other numbers prior to it, that doesn't put me at any different advantage that it does anyone else who has a Social Security number that ends in a different number. Okay, most of us will have Social Security numbers at some point. Some might not. It's okay. But a Social Security number would be a category. It's not something I'm counting. Okay? Social Security numbers provides a label. Student ID number is another quality thing for you. It's a qualitative thing. Your student number, all of you should have a different student number. Your student number, someone might have 1111 in their student number. That doesn't mean that they're any different than somebody that has 7273 in their number. And I don't know what your student numbers are. I imagine I could look them up, but it's just something to label categories. When I was in high school, I remember something changed. My freshman year, they would write on the outside of the doors. It would say, it had all the class, it would have the student's first and last name and the grade, and it was always listed from highest grade to lowest grade. Okay, that was posted outside the door. Think about that. So I'd sit there, oh, Chris Stirrup, because first name's Chris, last name's Stirrup. So I'd look, start at the very bottom of the list, and I'd start counting how many people are dumber than me. I didn't start at the top of the list. I didn't say how many people are smarter than me. I knew a whole lot of people were smarter than me. I just wanted to make sure I wasn't the bottom of the barrel. I mean, I kid you not. Everyone could see everyone's grades posted outside the doors. Then there's a, hold on. We're going to post it just by student number. That way people don't know. I kid you not. My student number when I was in high school is 895626. I graduated high school in 1989. I still know my student number. 89 because I graduated in 89. 5626 was just there. So they started posting with that. That would be posted outside the doors of classrooms. So it changed, went from first and last name to student number, because probably my group of friends and I were probably making fun of the people who were below us. Not that there was a whole lot below us. It was like one or two. So student number is a part of a category. It's qualitative. It's not something to be counting up. Okay, then you have discrete or continuous information. Now, probably the last time you heard about discrete or continuous was when you took Algebra 1, and then you never heard it again. And they emphasized it so much in Algebra 1, like, this is important. You got to know this. And now you're seniors, and you're like, oh, okay, Stirrup, I had you in Algebra 1. I remember every lesson you taught very well in Algebra 1. Right, Mikey? We'll do what I can. All right, so discrete versus continuous. Discrete would be, I walked into here and I counted how many students are here. I'm not going to have 30.273 students. Okay? You are a whole person. If you're missing body parts, you're still a whole person. If you're in a wheelchair, you're still a whole person. We don't count people by missing appendages or anything like that, or anything like that. Discrete. So we're counting. There's an actual hard count. Money is also discrete, and this is where a lot of times people get confused between discrete and continuous. Money has 2 decimal places. If you buy gasoline, it has 2 decimal places and a fraction. Did you ever notice that? Gasoline is 3.96 and 9/10. So 3.96 and 9/10. Doesn't even make sense. All the stuff we've been teaching all along, go to the gas station, they just wreck it. Do you think they should just either bump up the 1/10 of a cent? So we don't have this 9/10. No? Or maybe just round it out down. Okay, well, I'm with you. Yeah, you have a decimal with a fraction at a gas station. It doesn't make sense, never made sense. There's a reason why the petroleum companies are trillionaires, but hey, it is. But discrete is money as well, because you have a terminating decimal. Okay, continuous would be, I could ask you what your height is. Now, a lot of people could say, you know, I'm just about 6 foot tall. Are you exactly 6 foot tall? Well, just about. Okay, then we could break it down a little further. We say, okay, you're just about 6 foot tall, so are you 5'11"? Yeah. Are you really exactly 5'11"? Yeah. Are you sure? And then you get that, you know, meter stick that has millimeters on it, and now you're counting from inches into, you know, metric. But hey, so you could find different increments. There are certain people that, you know, I think I am 5'9". I go to the doctor every year, and I go between 5'10" and 5'8". And it's really rare that it's like, yeah, you're 5'9". And I always look at the doctor going, you got to help me out here. How am I? There's a 2-inch difference in my height. So, oh, you probably stretched out. Okay, there we go. So height, if you had really, really accurate measuring things, we could measure somebody in angstroms. Anyone know what an angstrom is? No one's heard of that term? Sorry, I'm going to geek out a little bit with chemistry. An angstrom is a unit of measure. It is 1/1000th of a millimeter. An angstrom is the distance from the nucleus of a hydrogen atom to its one single s orbital electron. That's small. Sorry, I had to geek out a little on that. So those are some of the things. So discrete, you have a hard count, continuous, you're going anywhere in between. Your oven, when it heats up, you turn your oven on at home or wherever, it's not going to go from room temperature all the way to the 350 degrees immediately. It's growing gradually through all of the temperatures, and then the thing, if it's like my oven, would beep when it gets to the temperature that you put your food in. So that would be continuous. Though temperature, it's like, what's the temperature of this? Well, if you have a thermometer, let's face it, after COVID, I bet you every household out there got that digital thermometer you put on your forehead and gave you 1 decimal place. Well, you're not exactly that temperature. You're slightly above that or below that, but it has to round off. It truncates at a certain point. But temperature itself will continue to gradually rise. So it's a continuous variable. Let's see. Why is the distinction between discrete and continuous important? Discrete variables are trapped into specific outcomes. The number of students in a class, we talked about that. It's not possible to have a portion of a student. Everyone's counted. And Mr. Anderson says, unless you have a student standing in the doorway, but that's not going to happen unless you want to. Discrete variables include ACT, IQ, the number of emails you receive each day, the price of gas, the number of siblings you have. Continuous variables are more flexible. The amount of precision and the outcomes can be chosen by the researcher and will be based partially on the instruments at hand. If we were measuring temperature, we might choose to use only whole numbers for temperatures, but we could have a lot more accurate. So beware, many continuous variables appear to be discrete. When you discuss the height of people, it is common to discuss in terms of feet and inches. The variables appear discrete. It is important to note that the choice is to round to a whole number. Height could certainly be measured more accurately than that. And that's what I have to teach you. All right, so this packet, as your book, once you go get it, and I'll let you take a picture if you need of the book itself, but this is good for a couple of weeks, or this week and next week. The homework for this, and I'll give you the rest of the period of time, work. You can work with each other, talk with each other, but look at page 97, 98. Do the best you can to do it. What I'll do tomorrow when we come back to class is I'm just going to kind of spot check. Did you attempt all of it? Attempt all of it. Does that mean it's all right? No.